Up and running. Nice early time this morning. Good time to do a little math. Yeah. All right. So going to look at a couple of simple things, I hope, and that might help you understand what you're looking at a little bit better. I can see that the lighting isn't great here. I'm out in the hallway trying this. Yeah, let's go for it. All right. So we got our basic parabola x squared. We want to hit a height of 9. I think pictorially, we can see that that x value, 3 units from 0, gets us the area we want. And so does -3. And so we're looking at squaring. And some of the principles of squaring are as follows. 2 times 2 is 4. So is -2 times -2, still 4. So we're seeing symmetry. 3 times 3, 9. 5 times 5, 25. Further you go from 0, the bigger the answer. That's for sure. And it seems like there's one number that's singular, and that's the output of 0. And I think we can see that if this was an ever expanding square and we went backwards with the area, we can see that the areas are getting smaller and smaller and smaller until we actually have no area, which means that this is a minimum. So there is a minimum to the squaring process. And we've been looking at ways of finding it. Hopefully minus b over 2a is popping into your head already. We can think of measuring change in 2 directions, but let's go with the positive. Let's be discriminatory because it's easier to work with the positive numbers because we work with them for longer. And I think we can see that when we get to 3, we could make a square, would have 9 units of area. All well and good. All right, so what happens if we shift our perspective a little bit? If we create a new axis, the x-axis starting from 0, well, what if we wanted to measure from the number 5? Well, it seems to me that we just took 5 units away from our previous axis. And so when we measure from 5, a statement like this seems to help us keep track of the amounts generated when we do different things operationally, squaring, cubing, square rooting, so on and so forth, from the number 5. All right, well, in this case, we're squaring. Seems to me that we have a similar picture, except we have to get to 8 in order to produce that same amount. All well and good. And I think we could probably draw a square and not call it x times x, but call it x minus 5 times x minus 5. And when we drop 5 in, yes, we don't have any area. And when we drop 6 in, get an area 1. We drop 7 in, we get an area of 4. And we drop 8 in, we get the area 9. Okay, all well and good. Now, what happens if we shorten the y-axis? I don't know why I erased that. Let's see if I can stand over here. See if it still captures it. Yeah, so we've got the y-axis from the origin, right? Here's the origin, boom. And if we erase 9 units, well, it seems like we get a measurement that similar to the thought process of x minus 5, but now it's y minus 9. Of course, we could always bring that 9 units over, and that would seem to read better for us. Of course, I've got to try to shift my computer over. See if that captures the screen here. Oh, I forgot that there was this wooden seat in front of me, and I just walked into it. Hello, Shin. Where are we now? We are, okay, can I see? Yes, I can see everything, and I'll walk around that little piece of wood this time. So hopefully that starts to look familiar. We've certainly been putting quadratics in graphing form. So hopefully we can see a vertex of 5, 9. And I think I already talked about that, so I can bring over here because I've already got that picture on the board and drawn a little better. So here's 5, 9. Here's the parabola. And let's look at a height of 18. Well, it's very similar to the earlier pictures, as in we're still going over 3 units to 8 and then squaring it. And that's giving us 9 units of change. And if we were already at 9, that's bringing us to 18. So I hope you can see it here. Dropping in an 8 or a 2. Either one of those gets the job done. All right. And we have new axis here, the x minus 5 axis and the y minus 9 if we bring the 9 to the other side. And maybe that's why we start with point slope. Yeah, point slope of a line, you know, y minus 3 equals 5 halves x minus 7. Point slope of a line. And I would very much like to see every textbook change and bring that 3 over here, because now we have more of a left to right orientation when we process calculations. And it's easier to move from left to right because we're used to reading that way. So please feel free to move those constants to the other side because it fits the graphing forms that we're going to develop throughout the year. All right, so where am I going with this? All right, well, you know, we could have thought about this thing going 9 in the other direction. And if we had, we would have found our roots. Our roots are when we hit, and I think we can see 2 and 8 here. Right, I think, let me draw this. Now, instead of going up 9 units, we're at 9, 18, we're going down 9 units. If we simply had a sign change, we simply sent the quadratic relationship in the other direction. And for many hundreds of years, solving this, let's go back to solving this. So let's put this 9 back on this side, and let's put a y equals 0 on this side. So solving this equation for 0, well, the mathematician said no real solution. Again, left to right orientation, I'll put the 0 on that side. It's a whole lot easier now mechanically to solve. So we bring the minus 9 over. The inverse of square rooting is squaring is square rooting with a plus minus because of the symmetry. And then we bring the minus 5 over as positive 5. We're still measuring from 5, right? Movement from 5, once in the positive direction, once in the negative. And this seems to symbolically, at least, tell us that we've hit right to 0. All right, so let's develop this concept a little further. Back to where we originally started. Let's do 3 times 3. 9. Yeah, but 3 could have been written as the square root of 9 times the square root of 9. And that's 9. It's got to be. And we've been working on that in class. Been working on that a lot with our what's the square root of 7 times the square root of 14 problems. Rewriting it as the square root of 7 times the square root of 7 times the square root of 2, and recognizing that picture where the square root of 7 times the square root of 7 has to give us 7. So mathematicians at some point said, well, let's move the computer. That's what they've said for thousands of years. Let's move the computer over so that we can see the board, even though it's in shadows. Well, here we have the desire to make this thing turn in the other direction. A sign change does that, right? So let's see how we can get that. Well, if this is -1, square root of 7 times square root of 7 is 7, then it sure looks like the square root of -1 times the square root of -1 mechanically does it. And you say, but you can't find a number that times itself that gives you a negative. That's true. But, you know, at some point in history, somebody said you can't find a number times itself that gives you 9, maybe. I don't know. Way above my pay grade, but it works. And so mathematicians have decided to call this the letter I. Because that's awkward writing that, keeping track of that minus sign. And so I times I is I squared, and we're going to call that -1. And we're going to do 3 or 4 things with it mechanically. We're going to practice a few things with it. And that video has already been made, so I'll just attach it. to this one perhaps. SAT work, we're going to look at conjugating. We're going to talk about what do you do with 4 minus 3i? What do you do with it? How do you rewrite that? We're going to find ways of saying 8i to the 93. How can we simplify that? And of course, we're using it in this context where I'll solve an equation now. Let's see if we can. I should have brought some eraser fluid here, but let's get a basic equation here. Let's say, how do I want to do this? Yeah, let's just put it in graphing form. Let's say we have 2 times x minus 3 squared plus 7. And we want that to equal 0. Well, it doesn't look like it will. I mean, it's going to be one of those minus. It's going to be, our answer is going to be, and we've been practicing in class, so I'm just going to get it up there. Right now, we're going to say 3 plus or minus the square root of minus 7 over 2. That's what's going to work. All right. And what I'm suggesting is that we take this negative sign out. Okay, so square root of negative 5, for instance, could now be written as the square root of 5 times the square root of negative 1, doing what we've been doing with numbers that are always positive here. All right, and so we're going to call this I. That's where we're going to be headed, and that's where we're going to be practicing. All right, so I have now a negative here, so it's really the square root of 7 over 2 times the square root of negative 1. I could have written it that way, and we're going to call this I. And I'm just going to show you how the number works in the equation. So we're going to put 3 in here. Good reason. We're getting rid of the other 3 here, the minus 3. Okay, so there's a good reason for that. Let's get a little space here. And I'll end the video on you just seeing how this works mechanically. All right, so I'm going to bring the 2 out here. I'm going to let x equal our answer, which is 3 plus or minus the square root of 7 over 2 times I. And then we're going to subtract 3. All right, let's just do it out. I think we can see the 3's disappear. That's good because those numbers don't help us get the change we need. I think when you square a positive or a negative, because you got to square things first, it's the most challenging operation in this mathematical sentence, you always get positives. I think I can see that. And I think squaring a square root is exactly what we were doing when we were looking at the square root of 9 times the square root of 9 equals 9. I think we were squaring a square root gives us what's inside. So that's 7/2. And I think squaring the letter I gives us I squared. And I think it hasn't been too long. It's been like 3 minutes since I said that I squared gets you -1. I times I squared gets you -1. Mathematicians decided to create something that gets the job done. So that's a -1. I think we can see that multiplying by 2 and dividing by 2, we've been working on that. Cancels. It sure looks like -7 plus 7 gets you 0. So that's where we're headed. We'll develop these concepts in class, but that gets us started, at least thinking about what we're doing. And I hope it helps. You might have to look at this a couple of times until it does help, until it makes sense to you. Okay, so good. I haven't been even in the screen with this table that's pretty low to the ground. So I probably will not make a video here again, but it's on there to help you. And see you in class. Righty.